Question number 4 on the handout of chapter 8, section 8.2. A researcher studying the public opinion on proposed social security changes obtained a simple random sample of 50 of adult Americans and asks them whether they support the proposed changes. Here they ask 50 adult Americans. But if you continue reading the question, this might not be enough, because look at this next sentence. To say that the distribution of the sample proportion of adults who responded S is approximately normal, how many more adults Americans does the research need to sample in the following cases? There is two cases here. So yes, they sample 50 randomly, but looks like they choose 50 are not enough to make this sample distribution of sample proportion approximately normal. So they want to find more. So we don't care about 50 right now. We care about how many they need, right? Then we'll find that how many more they need than 50. So here's the idea here. To make sampling distribution of sample proportion, again short form, to make STOSP normal, they choose 50, but looks like that's not enough, so they want to do more. The question asking how many more they need, right, in these two situations. As you said, this is the part A and this is the part B. Okay, I just number incorrectly. So in the part A, 10% of all adult Americans support changes. So here 10% represent P, because this is the percentage of all adult American. So P equals 0.10. So use this number 0.10 population proportion to find how many sample size needed to make sampling distribution of sample proportion normal. So there's a criteria we just did before. This criteria NP 1 minus P greater than 10 must be satisfied. There's two, by the way. This first one must be satisfied to make sampling distribution of sample proportion approximately normal. So here you put the value of P1 minus P, because I'm looking for N. I know this 50 is also sample size they pick, but that's not enough, so we ignore this for a moment. So we put N as a N, so P 0.10 and 1 minus 0.10 is greater than or equal to 10. So let's simplify this left hand side of the inequality, 0.10, and this is going to be 0.90 is greater than or equal to 10. And if I multiply this two number, I will get some value which is 0. Let me see, calculator here, 0.09. Okay, and 0.09 is greater than or equal to 10. So you divide by 0.09. This is the inequality you got to solve, 0.09, and this cancel. You get N equals greater than or equals to, if you divide 10 by 0.09, you get 111.11. So the sample size must be needed is 111.11 and more, because it's greater than. So basically 111.11 is same as 112 as a sample size. You always round up to the nearest whole number. So 111.11 is 112 when you round up to the whole number. So basically we need this much sample size. We need 112 sample. Okay, but how much they pick? They pick 50. That's not enough. So I should say they decided to pick 50. Okay, but that's not enough. So how many more they need? So 112 actually they require for sampling distribution of sample proportion to be normal, but they pick 50. So if you subtract 50, the difference is going to be what? 62. So more needed to make sampling distribution of sample proportion to be normal. So that's the question. The question asks you how many more they required. So see how many more do the researcher need to sample in the following case. I did for A for 10%, they need uh, uh, 62 more than 50, so it's going to be altogether 112. So for the part B, similar to part A, you just replace 0.10 by 0.20 because 20% as a P, and you follow the same steps. You get N is greater than equals to 62.5. Again, you follow the same steps. Okay, you show the work. So this about 63. So how many more needed? Because there is 50 they decided to choose, but they need 63. So they need 50, 63 minus 50, which is going to be 13 more needed if they want a proportion P as 0.20. Remember that in this case, this 0.20 is a P, like 0.10 in the last questions. Here P is a 0.20. You just follow the same steps as part A and you find how many more needed. Okay, that's the question number 4. And also question number 5, the last question of this handout, is going to be similar to the question number 4. Let me do that for you. It's exactly similar. Okay, so if the population proportion is believed to be 0.55, so here P gonna be 0.55 because it's a population proportion. Okay, how many items must be sampled? So in this question you're looking for N value, because how many items must be sampled, that means looking for sample size, to ensure that the sampling distribution of sample proportion will be approximately normal. So the question is asking for how many sample size needed to ensure, or I should say to make sampling distribution of sample proportion approximately normal. Okay, that's the question. So same idea here. We need this criteria to be satisfied: NP 1 minus P greater than or equals to 10 to make a sampling distribution of sample proportion approximately normal. And I use the same technique as before here to find how many sample size needed to make sampling distribution of sample proportion approximately normal. So here N, that's what I'm looking for. P 0.55, 1 minus 0.55 is greater than or equals to 10, and you do this in the calculator, you get N. If you do 0.55, 1 minus 0.55 altogether, you get 0.2475 is greater than or equals to 10, and you divide by 0.2475 divided by 0.2475. That's how you solve the inequality. You get N greater than, if you divide 10 by this number, you get 40.40. So this is 41. Again, round up. Okay, round up. So the question is how many items must be sampled? So answer is 41 items must be sampled. That's the answer. Okay, basically in this question you're looking for sample size. All right, that's all about this handout.